Okay, good afternoon. Good morning. So I'm going to continue the fourth session on Expolog. I've already uploaded three exercises on exponential and logarithmic equations. And I will first answer the question given in the chat box. Okay. Here's the problem. 3 times 9 to the x plus 5 times 3 to the x minus 2 equals 0. Okay, so for this one, you let u be equal to 3 to the x. And then your 9 to the x can be written as 3 squared to the x. And you multiply the exponents. That becomes 3 to the 2x, which can also be written as 3 to the x squared. 2 times x is the same as x times 2. Okay, don't forget that a to the m to the n is equal to a to the mn. So it's just u squared. So it will become a quadratic equation. If you rewrite this one in terms of the new variable, it's 3u squared plus 5u minus 2 equals 0. And then you factor out this quadratic equation by trial and error, though there's a systematic way of doing it. Okay, let's see if this combination will work. U and 6u. Okay, that's the correct factorization. Negative u and 6u makes 5u, then negative 2. And you get two possible answers for u. U equals 1/3 or negative 2. And then you do cases. Since u is equal to 3 to the x, so case 1, 3 to the x is equal to 1/3, and case 2, 3 to the x equals negative 2. Now for the first one, you can just answer it directly as negative 1, or if you don't see that, you can rewrite 1/3 as 3 to the negative 1, and you compare exponents, so x equals negative 1. Now for this one, there's no solution, since the exponential is always non-negative, always positive. You can never get a negative result when you raise a number to a power. So you don't get any solution from the other case. Okay, so the only answer for this one is negative. Okay, now let's try the one I'm more used to. They call this. The other is landscape. This is portrait. Tama ba? Sagutin natin lahat siguro to. So let's answer the first one. Logarithm of x minus 2 base 3 plus logarithm of x base 3 is equal to 1. Now what you do is write the left-hand side as a single logarithm. They have a common base. So we can write as a product. Log base 3 of x minus 2 times x. This came from the property that log of mn is equal to log m plus log n. Base 8. Logarithms, remember, bear in mind, convert multiplication to addition. This is multiplication on the left-hand side. It is addition on the right-hand side, and vice versa. You can write a sum of logarithms as a single logarithm, and that's what we did here. So here is a product. If you separate the two, you will just get back to this. Now, we have done the reverse. From a sum, we wrote it as a single logarithm of the product of the terms, x minus 2 and x. And we can rewrite this in exponential form, but let me first simplify the expression inside. That's x squared minus 2x base 3 is equal to 1. Now we convert this to exponential form by doing some they call this moving in a counter or hindi naman mahalaga ng clockwise manner in order to see where each of the expressions there will go. So it will become x squared minus 2x equals 3 to the 1. So 3 to the 1 equals this, x squared minus 2x. Okay? And so we have transformed a logarithmic equation into a quadratic equation. And this requires factorization again. Don't worry, all the problems that you will encounter will be factorable if you will be needing to solve a quadratic equation. So let's factor out this one. It's x minus 3 times x plus 1 equals 0. Okay, so you're giving you two possible answers, positive 3 and 1, or negative 1. However, this is a logarithmic equation. Unlike exponential equations, the domain of logarithms are limited to positive values. If you have a to the x, the domain is all real numbers for x. Now, if you have logarithm of x, base a, the domain is only the set of positive real numbers. That means if you get a negative value for x or a 0 value for x, it cannot be substituted into the logarithmic function. The logarithmic function will not be defined. So if we check our answers here, if I plug in 3, for instance, it's okay. 3 minus 2 is 1. Okay? And plug in here, 3 is positive. But if you plug in -1, this one here, notice here it will be negative and so here as well. So that means we have to discard -1 as a solution. It's an extra solution, we call it an extraneous solution. Actually, in the set of complex numbers, it is really a solution, but since we are only dealing with real numbers here, so we will have to discard that. So the only answer for this equation is this, 3. Is there any question on this? Let me check the chat box. Number 4, okay. Let me see that later. Okay, let's do number 2. Okay. So one approach would be to just write it as a single logarithm on both sides, since we already have a single logarithm here. There's not much changing to do, although we have to raise this to as an exponent of the expression inside the logarithm. But this one can be written as a single logarithm. We multiply them together inside the one logarithm outside. So we have the left-hand side as that. And the right-hand side becomes ln x plus 1 squared. Remember, you can bring down the exponent beside, and you can do it the other way around. So we raise up this one here. And since you have base E, that means you just have to equate the expressions inside. So this gives us the quadratic equation, x minus 1 times 2x plus 3 equals x plus 1 squared, which we just have to solve and then check later on for extraneous solutions if there are any. So let's answer. Let's solve 2x squared and then negative 2x plus 3x is 1x and then minus 3. And then x squared plus 2x plus 1. And then put all on one side, we get this one, x squared minus x minus 4 equals 0, which should be factorable. So x minus, let's see, is this factorable? X minus 4. Did we do something wrong? Okay, let's check. 2x squared. Okay, that's correct. Negative 2 plus 3. That's correct. So minus 3. Okay, nothing wrong. So that's correct. Minus 4. 4 and 1 makes 3. 2 and 2, wala. So in this case, just for the purpose of illustration, although I won't be giving one like this in the exam where you have to use the quadratic formula, but using the quadratic formula, we have negative b plus minus square root of b squared minus 4ac over 2a. So 1 plus minus square root of 17 over 2. And I think you will have to omit the one with the negative since it will make this one negative. So the only answer actually here should be 1 plus square root of 17 over 2. But since this requires the use of the quadratic formula, safe to say that you don't need to worry about encountering a problem like this in the exam. So it's just problems like this where you have factorable expressions. Okay, let's do number 3. How do we do this one? Okay, we must always be able to write both sides as a single logarithm. Now notice the left-hand side is already a single logarithm, but the right-hand side is not. So one approach would be to try to write that side as a single logarithm, and it can be done. But there's something you can do first to avoid that what we call this, that approach. You can first transpose everything that has logarithms on one side of the equation, those without logarithms or logarithm on the other side. So notice this one does not have a logarithm, only two terms contain a logarithm. So we will transpose this one to the left-hand side so that all logarithms will be on that side. And then write that side as a single logarithm. This is now minus, so we divide inside that one logarithm. So 3x minus 4 over 2x plus 1 equals 1/2. So we have achieved our purpose so far, to express one side as a single logarithm. Now this is a logarithmic equation. We will transform it to an exponential equation. So we write it as 4 to the 1/2 equals 3x minus 4 over 2x plus 1. Okay, and then solve. So 4 to the 1/2 is 2, and then you can cross multiply. Okay, so giving 3x minus 4 equals 4x plus 2 after cross multiplication. And then you get x equals -6. Okay, but are we done here? Is that the final answer? It's not the final answer since it's really an extraneous solution. Once you plug into the original equation, the very question given, it will not be defined if we plug in -6. So for example, if you plug in -6 there, it will become log base 4, so 3 times -6, -22. And logarithm of -22 is not a real number, it's undefined in the set of real numbers. So if there is a multiple choice question and you see none of the above or perhaps an empty set, that would be the one you have to choose, or you just write none in the, if it's a fill in the blanks. Okay, or maybe if you know how to use Canvas well, you can put in the empty set itself or this sometimes set that contains nothing. Anyway, it will be manually checked, so doesn't matter how you write down your answer as long as it's correct. Any questions so far? Okay, let me just do one more on this. Number 4, log x quantity cubed equals log of quantity x cubed. Now, this could be a tricky problem since one of the exponent is inside the logarithm, another is outside the logarithm. This is outside, while this is inside. So, how do we solve this one? Well, you do not apply the property wrongly by bringing down 3 here. That's not allowed since 3 is outside the logarithm. You can only do it if it's inside the logarithm, as in the right hand expression. So this one you can bring down. And it takes perhaps keen observation to notice that log x is a common expression there, which you can set as your new variable, your dummy variable, to transform the equation into an algebraic one. So if you set u equal to log x, notice it will just become u cubed equals 3u. Tama? Naging ano na lang siya, no? Polynomial equation, algebraic. So this is solved by transposing everything always on the other side. Don't cancel out u. You'll miss one of the solutions. You transpose, never cancel when solving an equation, and then factor out, giving you 3 possible answers for variable u. Okay? By the way, I got plus and minus, since if you set, okay, u squared minus 3 equals 0, you'll get u squared equals 3. And since you are solving for all possibilities, you have to include the negative solution. And you go back to x, revert to x. So u equals log x. So you have log x equals 0. And you have log x equals plus minus square root of 3. And remember, this is base 10. So you can do, again, that, we call that process, or, so x equals 10 to the 0, x is 1. And then same thing here, there's base 10, which you can rewrite as an exponential or in exponential form. So giving you x equals 10 to the plus minus square root of 3. So there are how many possible solutions? 3. So we just check if they can be substituted into the original equation. Can they? Yes, we can plug in 1. Okay, no problem with 1. We can also plug in both of these since they are non-negative. No, don't be bothered by 10 to the negative square root of 3. It's just 1 over 10 to the square root of 3. And that is still positive. So if you plug in here, so no problem. You get non-negative or positive values. So those are the answers. 1, and then 10 to the square root of 3, and then 10 to the negative square root of 2. So you may try number 5 for your practice, and then just before next, or by the weekend perhaps, I'll be able to send you more exercises on logarithmic equations. Okay. Is there any other problem you want me to solve before I try the next set, or do the next set for your review as well? Mukhang dito nalalabas lahat yun. Okay, let's do just 2 of this part. Ito siguro. Okay. Gawin ko muna yung number 12. Yan yung pinaka-simple dyan. 19 to the x equals 11 to the x minus 1. So all you have to do, since they have different the bases cannot be expressed using a common base. So we have to resort to logarithms. And we will be using ln instead of the common base log 10 or base 10. So ln of the left-hand side equals the ln of the right-hand side. And then you can bring down. X ln 19 equals x minus 1 ln 11. So x distribute. This is just a number. So you can distribute. So x ln 11 minus 1 ln 11. And then collect all with x on one side. And then factor out the x. And then divide by this. Bring that down. Which you can also write as, if you want to avoid that negative, you put it below, you distribute it. So that becomes ln 11 over ln 11 minus ln 1. But this is acceptable. Okay, I'll give you some time to work out number 13. So just take the logarithm of both sides. And then dito gagamit kayo yung division, yung multiplication magiging addition. This one. Okay, siguro mga 3 minutes. Regarding your question, sorry ngayon ko lang nabasa, Mr. or Miss Sanchez. Yes, 3 times 9 to the x yun. Kasi kung 39 to the x yun, walang solution. May solution pero hindi kaya ng methods natin. Okay, let us show. So if you take the logarithm of one side, you split the two factors there. And then you bring down the exponents. And then distribute. And then collect all with x on one side. Let's put them all on the left-hand side. Then those without x, the other side. Okay, so ln5 minus ln3, then the negative ln7 comes a plus. Then you can factor out the x. Then equals this, you can bring it down, you get ln5 minus ln3 plus ln7 over ln7 minus 25. Now, if you are required to give a numerical answer, you have to press these values into your calculator and give the answer to the required number of decimal places. But if not, you may be required to either input that or you have to choose among the choices. It is a multiple choice format type of question. Okay, so I'll leave the others there to you. Let me do the next step. Okay, gawa lang tayo ng dalawa siguro dito. Okay. So let's do itong number 18, kapareho yan yung tinanong sa akin kanina. Yung unang-unang ginawa natin. Let's do number 21. Pare-pareho lang naman actually lahat yan. I can just answer one or two. So solve that one for x. And same as with the first problem I answered. You use a transformation. Let u be equal to 3 to the x. And just note that you can write 3 to the negative x as 1 over 3 to the x. So that will be 1 over u, since u is 3 to the x. So we can rewrite as u, this one here now, equals 1 over u plus 8. And solve this algebraic equation first. So we multiply everything by the LCD. So left-hand side is u squared, right-hand side is 1 plus 8. So it has become quadratic. So it's factorable. No. Okay. So, sige, sagutin natin dahil no choice ako. So this is not factorable. So you will have to apply the quadratic formula. So you get those. 60 is 15 times 4. So yan. Pag sinimplify siya, okay? And that's not yet finished. You have to revert to x. So remember, u equals 3 to the x. So that's this one. And that means you have two cases actually. Let me do the first one. So how do you solve for x here? Well, you just use the technique we used a while ago. Take the logarithm of both sides. And you can bring this down. That becomes xln3. Yeah. And then you can divide this, divide everything by that, or bring it down. And you do it the same for the other. Hindi naman ito magne-negative. Positive pa rin yan. If it is negative, then there's no solution for that case. Papalitan mo lang naman. Okay, so let's try another one. Pareho lang sila talaga. Pero, okay, ano ba maganda dito yung ano na lang. 3 times 4 to the 2x plus 5 times 4 to the x minus 1. So the transformation would be given by this, okay, relation, u equals 4 to the x. So pag nire-write mo kasi yung una, it's just 4 to the x squared. So it's u squared. Then it becomes quadratic. Factorable, no? Anong kapareho ng kanina? U and 6u. Okay, tama. 6u, okay. So makuha natin 1/3 tsaka -2. Halos pareho nung kanina pero ang pinagkaiba nito base 4. So let u be, since u is equal to 4 to the x, so 4 to the x equals 1/3. Tsaka 4 to the x equals -2. Ito automatic, wala nang solution to. Negative kasi yung, hindi pwedeng mag-negative yung ano, exponential. So this one, you just take the ln. Okay, ln 4 to the x equals ln, I'll write 1/3 as 3 to the -1. Bring down to binaba. So x is negative ln 3 over ln 4. So yun sagot natin. It takes practice para makuha nyo talaga ang Expolog. Okay, let's try the other set. the last one there. Okay. Hindi na natin lahat. Okay, solve for the indicated variable in the following equations. Let's just do 26 and 28. Okay, solve for t in this one. I equals E over R1 minus E to the negative RT over L. We are going to solve for t. Now notice where t is up there. So we have to be able to bring it down somehow. And we know what undoes exponentials, logarithms. And since this is natural base, we will have to use ln again. But first, we need to be able to isolate this term, and that is by performing some algebraic manipulations first. So I will be multiplying by r over e. Okay, notice what happens if I multiply by r over e. This e over r transfers here. O parang cross multiply lang yan. So IR over E, yan na, 1 minus E to the negative RT over L. We're trying to isolate this one, this term. So kailangan mailipat natin yung iba sa lahat ng iba sa kabila. So depende sa diskarte, ganito na lang gagawin ko. Pwede namang ilipat mo yung 1 dito. Pero dahil ayaw ko itong negative na to, ilipat ko to dito, ito dito. Okay? Pareho rin lang naman yung kalalabasan. And then we're solving for t, so we take the ln of both sides. Sorry, I just noticed the chat box. Yes, pwede rin naman nag-iba lang konti yung sign, Mr. Hugo. Or okay. Okay, now remember the identity ln e to the x is equal to x. Ln and e are inverse functions. So the left-hand side just becomes negative RT over L. And then you solve for t by cross multiplication, you're done. Or sometimes you may simplify the fraction there using the LCD. There. That's t. Okay, any question on this? So let's do number 28. Ito, halimbawa, hinahanap mo yung inverse function. Paano mo nga hanapin? So, yung technique na gagawin ko dito, yun din ang gagamitin mo. Mag-i-interchange ka na lang ng x and y afterwards. So here you're going to solve for x. So cross multiply. And then collect all with x on one side. Those without x, other side. Okay, dilipat ko to. And then factor out 2 to the x. Bring down. And then, okay, there are two approaches to this. Since you're only solving for x, okay, ganito gagawin ko muna. Ln both sides. So if you do that, the left-hand side becomes x ln 2. And then there. X equals there. Okay, that's one possible way of writing the answer in terms of the natural logarithm. But if this were a problem on finding the inverse, okay, ganito ang mangyayari dyan. You have to write this in logarithmic form. Nasa exponential form siya. Ano yung base natin? Base 2. Ano yung input? Ito. Ano yung output? Ito. So pagpalitin lang natin yung input tsaka output, logarithm base 2 tayo. Ito ngayon ang input. So yung output x. And you're done. So x equals, in terms of y, logarithm of y plus 1 over y minus 1 base 2. Pareho lang yun ng sagot kanina actually if you know how to convert bases. Pero hindi ko na sinama yun sa coverage. But ito, dagdag lang. Kung inverse ang hahanapin mo, anong gagawin pa? Final step. Diba you interchange x and y? If you're looking for the inverse, if you're only required to solve for x, you stop here. So the inverse function, if this were f, if the original one were f of x, so that would be your inverse, f inverse of x. Yan siya. So, is there any other question that you would like me to answer before we end? Now, kung mahirapan kayo mag-solve ng iba, may consultation pa naman. Now, this will be, I think, our last session na kasi. So sa Thursday, bibigyan ko kayo ng time mag-review. So available na lang ako for consultation siguro by Friday. Okay, so yung long test natin, yung quiz natin, expect ganito siya, 20 items. Hindi siya ganun katagal gawin kada item. Okay, so 2 points each yon. Sa halos parang all or nothing na rin talaga. So mas marami usually devote dito sa Expolog na mga questions. Huwag niyong kalimutan yung exponential growth and decay. Hindi ko na ma-discuss yon live, pero nagbigay ako ng videos na sa mga nakaraang semesters. At siguro meron pang mga exercises na ibibigay ako sa video. Okay, so paki-aral na rin yung dalawa pang Expolog na in-upload ko kanina. Kasama ito sa i-upload ko. So I'll be ending the class.